Imagine watching a movie where dinosaurs leap off the screen, or a documentary where you feel like you're swimming with sharks. 3D glasses make these incredible experiences possible, transporting us to another dimension from the comfort of our seats. They're like magic portals that trick our brains into perceiving depth and dimension, adding a whole new layer of excitement to movies, games, and even educational content. Remember the first time you put on a pair of 3D glasses? It was like stepping into another world. Suddenly, objects on the screen had depth, popping out towards you or receding into the background. You could almost reach out and touch them. This mind-bending experience is the result of clever science and technology that work together to fool our brains into seeing 3 dimensions. But how do these seemingly simple glasses create such a powerful illusion? Our eyes are amazing organs, capturing light and sending signals to our brain, which interprets these signals as images. But our vision is more than just seeing. It's about understanding the world around us in 3 dimensions. This ability to perceive depth is crucial for our everyday lives, from walking down the street to interacting with objects. The key to our 3D vision lies in the fact that we have 2 eyes, spaced slightly apart. This separation means each eye captures a slightly different view of the same scene. Think about holding your finger in front of your face and closing one eye at a time. Notice how your finger seems to shift position slightly? That's because each eye is seeing it from a different angle. Our brain is a master at processing these 2 slightly different images. It combines them, taking into account the differences in perspective, to create a single 3-dimensional image. This process, called stereoscopes, is what allows us to perceive depth, judge distances, and understand the spatial relationships between objects. Without stereoscopes, our world would appear flat and 2-dimensional. We wouldn't be able to accurately judge distances, making tasks like driving, playing sports, or even pouring a glass of water incredibly difficult. It's thanks to our 2-eyed vision and our brain's remarkable processing power that we experience the world in all its 3-dimensional glory. 3D glasses work by mimicking the way our eyes naturally perceive depth. They create the illusion of 3-dimensional images by presenting slightly different images to each eye, tricking our brain into perceiving depth where there is none. This clever manipulation of light in our visual system is what makes the 3D experience so immersive and captivating. There are several types of 3D glasses, each employing different techniques to achieve this illusion. Some use colored filters, others use polarized lenses, and some even use electronic shutters that rapidly alternate between each eye. Regardless of the method, the goal is the same: to ensure each eye receives a slightly different perspective of the image. These different perspectives, when combined by our brain, create the illusion of depth. Objects on the screen appear to pop out towards us or recede into the background, just as they would in real life. The brain is fooled into believing it's seeing a 3-dimensional scene, even though it's actually looking at 2 flat images. This remarkable feat of visual trickery is what makes 3D technology so compelling. It allows us to experience movies, games, and other media in a whole new way, adding a layer of immersion and realism that simply isn't possible with traditional 2-dimensional displays. It's a testament to our understanding of vision and the creative ways we can manipulate it to create amazing experiences. The quest to create the illusion of 3-dimensional images dates back centuries. Long before the advent of modern 3D glasses, inventors and artists experimented with various techniques to trick the eye into perceiving depth. These early attempts laid the groundwork for the sophisticated 3D technology we enjoy today. One of the earliest examples is the stereoscope, a device invented in the 1830s. It used 2 slightly different images viewed through a pair of lenses to create the illusion of depth. This Victorian-era gadget became a popular form of entertainment, offering glimpses of faraway lands and exotic scenes in 3D. Another early technique was the anaglyph, which used 2 overlapping images printed in different colors, typically red and blue. When viewed through glasses with corresponding colored filters, the brain would combine the 2 images, creating a 3D effect. Anaglyph images were popular in print media, comic books, and even early 3D movies. These early attempts at 3D, though rudimentary by today's standards, demonstrated the enduring fascination with creating immersive visual experiences. They paved the way for the development of more sophisticated 3D technologies, including the various types of 3D glasses that have become synonymous with modern 3D entertainment. Anaglyph glasses are perhaps the most recognizable type of 3D glasses, instantly bringing to mind images of classic 3D comic books and retro movie screenings. These glasses, with their iconic red and blue lenses, represent the earliest mainstream foray into 3D technology, introducing generations to the captivating world of 3-dimensional imagery. Anaglyph glasses work by exploiting the way our eyes perceive color. 2 images of the same scene are superimposed, one tinted red and the other blue. When viewed through the anaglyph glasses, the red lens filters out the blue image, and the blue lens filters out the red image. This ensures that each eye sees only its designated image. The brain then combines these two slightly different images, creating the illusion of depth. While anaglyph technology is relatively simple, it effectively demonstrates the principle of stereoscopic vision, tricking our brains into perceiving three dimensions from two flat images. Despite their limitations, such as color distortion and a somewhat blurry 3D effect, anaglyph glasses played a crucial role in popularizing 3D. They made 3D imagery accessible to a wide audience, sparking curiosity and paving the way for more advanced 3D technologies. Even today, anaglyph glasses retain a nostalgic charm, reminding us of the early days of 3D and its enduring appeal. Polarized 3D glasses represent a significant leap forward in 3D technology, offering a more refined and immersive 3D experience compared to their anaglyph predecessors. These glasses utilize the principle of light polarization to deliver separate images to each eye, creating a clearer and more vibrant 3D effect. Light waves, like all waves, vibrate in different directions. Polarized lenses act like filters, allowing only light waves vibrating in a specific direction to pass through. In polarized 3D systems, two projectors emit polarized light, each with a different polarization orientation. The polarized 3D glasses, with lenses that match the polarization of the projectors, ensure that each eye receives only the image intended for it. The left lens allows only the left image's light to pass, while the right lens allows only the right image's light. This separation of images is crucial for creating the stereoscopic effect. The brain then combines these two distinct images, perceiving depth and creating the illusion of three dimensions. Polarized 3D technology offers several advantages over anaglyph, including a brighter image, more accurate colors, and less ghosting, resulting in a more enjoyable and immersive 3D experience. Shutter glasses represent the cutting edge of 3D technology, offering the most sophisticated and immersive 3D experience available. These glasses utilize liquid crystal lenses that rapidly alternate between opaque and transparent states, synchronizing with a high-speed display to deliver separate images to each eye. The technology behind shutter glasses is quite remarkable. The lenses are electronically controlled, blocking light from one eye while allowing it to pass through to the other. This rapid switching, occurring hundreds of times per second, ensures that each eye sees only its designated image, creating the illusion of depth. The synchronization between the glasses and the display is crucial for this process to work seamlessly. The display alternates between the left and right images at a high frequency, and the glasses shutters synchronize with this alternation, ensuring that each eye sees only the image intended for it. Shutter glasses offer several advantages over other 3D technologies. They provide a brighter and clearer image, eliminate ghosting, and offer a wider viewing angle. However, they are also more expensive and require a compatible display and power source. Despite these limitations, shutter glasses represent the pinnacle of 3D technology, delivering the most realistic and immersive 3D experience available. 3D technology has been around for decades, and with it, some myths and misconceptions have persisted. One common concern is that watching 3D movies or playing 3D games can damage your eyesight. This is simply not true. 3D technology, when implemented correctly, does not pose any harm to your eyes. The discomfort some people experience while watching 3D is often due to factors other than the technology itself. Poorly calibrated 3D systems can lead to eye strain, headaches, and nausea. This is usually caused by inconsistencies in the images presented to each eye, leading to visual confusion and discomfort. Another factor is the quality of the 3D glasses. Cheap or poorly manufactured glasses may not effectively filter light or synchronize properly, leading to a subpar viewing experience and potential discomfort. However, high-quality 3D glasses, when used with a properly calibrated 3D system, should not cause any eye problems. It's important to remember that 3D technology simply mimics the way our eyes naturally perceive depth. It doesn't alter the structure of our eyes or damage our vision in any way. So, rest assured you can enjoy the immersive world of 3D without worrying about harming your eyesight. While 3D technology is most commonly associated with entertainment, its applications extend far beyond the realm of movies and games. 3D imaging is revolutionizing various fields from medicine and engineering to education and scientific research, offering new ways to visualize, understand, and interact with the world around us. In medicine, 3D imaging is transforming the way doctors diagnose and treat patients. 3D scans provide detailed anatomical visualizations, allowing surgeons to plan complex procedures with greater precision. 3D printing is being used to create customized implants and prosthetics, improving patient outcomes and quality of life. In engineering, 3D modeling allows engineers engineers to design and test complex structures virtually, identifying potential flaws and optimizing designs before physical construction begins. This reduces development costs and improves the safety and efficiency in fields like aerospace, automotive, and civil engineering. In education, 3D visualizations bring learning to life, making complex concepts more accessible and engaging for students. From exploring ancient civilizations to dissecting virtual organisms, 3D technology enhances learning experiences, fostering curiosity and deeper understanding. 3D technology has come a long way since the days of red and blue glasses and cardboard stereoscopes. Today, we have access to sophisticated 3D systems that deliver stunningly realistic and immersive experiences. Whether it's the thrill of a 3D movie, the excitement of a 3D video game, or the educational value of 3D visualizations, the third dimension adds a whole new layer of engagement and wonder to our world. So, the next time you have the opportunity to experience something in 3D, don't hesitate. Put on those glasses and prepare to be transported to another dimension. Let the illusion of depth captivate your senses, and appreciate the ingenuity of the technology that makes it all possible. 3D is more than just a gimmick, it's a window into a world of possibilities, enhancing our entertainment, our understanding, and our interaction with the world around us. Explore the world of 3D with open eyes and a sense of adventure. You might be surprised at what you discover.